Hey, good afternoon. My name is David Helen, and I've been teaching computing in one form or another now since the late 1980s. I'm currently working with one of the many international schools in Prague in the Czech Republic, and I teach students from a variety of backgrounds from age 11 upwards, preparing them for IGCSE and IB Computer Science at ages 16 and 18. Now, what I'm going to be sharing with you is most relevant to Key Stage 3, that's 11 to 14-year-olds, but it can be successfully used with older and younger students. So over the next half hour, we'll be looking at some practical examples of how Google Slides can be used to help students solve a range of problems that involve structuring the data they have in a way that makes them ask questions, navigating through their data to find useful information, anything from creating identification keys and quizzes to writing interactive fiction. So a revolution is taking place, and you may have noticed a change in the curriculum recently. It doesn't mean that we've got rid of all the good, interesting things that we used to do in IT and ICT lessons, but there is now a change in emphasis. So what I'm going to be doing today is showing how one tool, Google Slides, can be used in an engaging way to help promote a new way of thinking in the classroom. Okay, we've found that it's not good enough for us to teach a set of skills to help our students use generic software like we used to. We've been aware that to be equipped as 21st century learners, our students need an additional dimension to their skills. One name for this is computational thinking. And we're not just talking about coding here. We're referring to the ability to construct and work with algorithms, to think logically, to identify patterns, generalizing and structuring data. And yes, being able to write programs is an important part of this, but it's not confined to computer science. One of the most interesting parts of Google's recent computational thinking course for teachers was that there were strands for specialist humanities, science and mathematics teachers, enabling them to investigate how to introduce computational thinking in their classrooms and then enhance their students' experience. Now, I've already mentioned data a few times in this presentation. You may be wondering what the big deal is here. Computational thinking is concerned with how we deal with data. Data could be words, could be numbers, could be photos, could be pictures, could be characters, could be music, could be sounds, could be animation. Data could be anything. If you can store it, and if you can process it to get information, it's data. But how we arrange and structure that data has an impact on the ease with which we can then get useful information from it. So that's the big idea I'm focusing on today, and I'm hoping you'll leave the presentation with some practical pointers on some of the strategies that you can use to help your students take their computational thinking skills just one step further. Now, what I'm advocating isn't new. I've been doing some of this stuff since the early 1990s with a shockingly wide variety of different resources, from logo to wiki markup to HTML, through Flash, Scratch, and a whole range of different presentation programs. And each approach has its own strengths and weaknesses. So we're going to start off by looking at how we can put action buttons on Google Slides. Now, this isn't going to be a tutorial on how to put buttons on slides. There's plenty of material on Google's training resources for you to find that out. And so you'd be thinking, oh, hang on, this is Key Stage 2. Some of my kids come to me from primary school being able to do this. But I get students from all walks of life, and many of them have never come across this before. And it's an amazing revelation to them that a presentation doesn't have to be linear, that it doesn't have to be slide 1, then slide 2, then slide 3, then slide 4, and so on. Instead, you can set up your presentation so there are multiple routes through your slideshow. Now, my year 7s take part in a project called Global Virtual Classroom. So one of the first things we do with our schools is set up virtual tours of card, so that by clicking on different buttons on different pages, they can choose the order with which they want to navigate their route through the city to see the different attractions. So, with presentation software being very common, with many students coming in at some experience of it, what is it about Google Slides that I like compared to, say, Microsoft PowerPoint or LibreOffice's Impress? So I'm going to go over 2 advantages. If in your classroom you find that you have the same issues, then obviously you may decide, yes, I want to do this for my students as well. So the first one, collaboration. Something to think about. If I wanted a small group to work collaboratively on a presentation in the old days, it might involve one of them working on the presentation for homework one night. They'd save it onto a flash disk, give it to another student the next night, and so on and so on. Each time, the student adding more material to it and then passing it to their friends. But if they forgot to make backups, if they had problems with different points, if they lost the flash disk, there are all sorts of potential problems due entirely to the limitations of the software and the hardware that they were using. Now with Google Groups and Slides, it's incredibly straightforward. Again, another example from our experience with Global Virtual Classroom. To have the students introduce themselves to their partner classes, I make a single presentation in Google Slides. I allocate 1 slide to each student in the class, and I share editing notes with them. And you can show them on your interactive whiteboard in the class how each change they make to any slide on the presentation is stored. So you can see who's done what in the entire presentation, and how in real time you can also see who's working on which part of the presentation. And I usually give them 3 questions to answer. And if it's the first time they've used slides, I may show them some simple image manipulation tools they can use to enhance their slides. But it means that in just 1 single lesson, we can collaborate to create an entire class presentation. Now imagine how long it would take if we were doing a presentation like that, but it could only be edited by 1 student at a time. And the other reason why I love Google Slides is because we can create Google Sites to act as a virtual binder to bring together all the work that a student has been doing. So the site embeds their documents, their slideshows, their spreadsheets, and so on. And the great advantage of this is that if they then update the original, what you see on their portfolio also updates. So those are 2 big reasons why I like slides. Obviously, if your experience matches mine, you may decide the same. Sometimes, however, other tools, other approaches are needed. And you may be thinking, oh, okay, this is such an old idea, something you've been doing since the 1990s. Why aren't you ditching it? Why aren't you just saying to your students, code all this stuff instead? And so this is my big idea, something that I learned from one of my students in one of my classes recently that I felt was really worth sharing with everyone else. And it's all about binary trees. Now, mathematicians amongst you will have realised that if you're asking yes/no type questions, then for n questions, you always have n+1 answers. But what's the maximum number of questions you need to ask? And more importantly, how can you structure your questions so it's the minimum number? Here's an example. One of my Year 9 students made an identification key which could predict what your favourite ice cream flavour is from a selection of over 30 different flavours. Don't ask how long he spent on this at home. And so I asked him, after he demonstrated to the class, what was the main thing that he'd learned? And he said, well, actually, I had to restart what I was doing because I realised fairly early on that I could have just had one question, which would be yes, no, and I could have just had a long line of over 30 questions. But it would mean that for some of the ice cream flavours, I'd have to ask 30 or more questions to find that out. So I rethought what sort of questions I'd have to ask to split them up. Fruit flavours, not fruit flavours. Do they have nuts? Do they not have nuts? And that way I could make it so that the maximum number of questions that people needed to ask was only about 6. Now, this impressed me so much because it meant that as a 13-year-old, he just worked out independently what I tell my IB computer science students, 17 and 18-year-olds, that when we study binary search trees, that the worst case you can come up with for a binary search tree is when the data is all sorted. But in the best case, we're looking at a much, much smaller number of searches, so that for 1,000 records, we only need to do 10 searches. And this is what excites me about the new curriculum and using these tools to help our students access it, because it empowers them to independently make such important connections for themselves. But as you've seen from my mention of virtual tours, it doesn't have to be identification keys. And if you're looking for quick things to do with the class to build up their skills, then there are a few other things that you can do. You can template out a blank binary search tree, make one up with 7 questions and answers for them to fill in. You can give them post-its to rearrange with a set of questions and answers on to see who can make the most efficient tree. But here's a couple more ideas. First of all, quick quizzes. And again, you could template something like this. But of course, there are disadvantages. Number one, this won't give you a score. And if you want intelligent feedback on which wrong answers you chose, it can involve an awful lot more work. But it's a great way for your students to make simple flashcards, and you can focus on what makes a good question instead of spending more time on what the technology actually does. Another one, and I love these. We've done this in virtual classroom a number of times. Students writing their own choose your own adventure type of story. So the action buttons got crucial points of the narrative, allowing for different plot twists and a range of different endings. And again, this isn't the only tool you can use to do this. I've had students use Logo, Python, and of course, programming languages give you the advantage of using variables to keep track of items that you collect to move the plot along. You can even use Google Forms, and the advantage there is that you can track the route they take through your data, where they visited, and also, importantly, what they didn't do. So Google Sites is one option, but I increasingly get asked the question, so when does it make sense to write your own programs to store data in some sort of tree structure? So here's a few ideas, a few thoughts just to finish off with before we take any further questions. First of all, if there's lots of data, If there's lots of data, you need to automate, because adding an extra slide for an extra question, adding an extra slide for an extra answer, and then modifying at least one of your slides in order to fit this new data in is an awful lot of work. Far easier to make it so that you just enter text for each new question, each new answer. Now, I love Building Blocks, or SNAP, by Berkeley in California, and one of the sample exercises they give you in SNAP is using a binary tree for animal identification, because the screenshot I've included. So for some of you, that might be something you want to discuss, you might want to investigate. But interactivity to me is the big key. You've got your data structure, but it's the user interface that matters. If they're faced just with a blank screen, that's not really going to help them, like this slide. But this is why I start to get really excited, because if you are coding your project, you can build whatever user interface you want on your screen. In fact, it doesn't even have to be on your screen. Why shouldn't you have a couple of massive buttons on your wall? Why not set up a couple of ultrasonic rangefinders to sense different areas of the classroom, so that when students move to one part or another part of the classroom, it records their response? You could even count them. Let your imagination run wild, or better still, unleash your students' imagination and see what amazing creative things they can come up with. Because when it comes down to it, the most important thing is fun. Give them a challenge, make it interesting. Now, I like Scratch as a programming tool as a first programming language. Within Scratch, you can use lists to store data. So I decided to see, is it possible to use several lists to store that data? So I came up with one example, tried to template it out, and what I will do on 3.142.org.uk, I'll put a link to some of the things that I've been going over, so that those who want to explore this and discuss this further, you can do so. Obviously, you can contact me via Twitter and Google+, and this will be recorded so that we can come back to it. And I'm not seeing any questions, so nothing. I'm checking to see if there are any other questions. I'm just seeing if there's any other questions anywhere else. In the meantime, just say hello again. Let's go now into the live events apart. That's interesting. Hopefully those of you who couldn't hear didn't actually get through. I can see someone else has been giving answers to that. I'm thinking one of the things I could do with the remaining time that I have is bring up one of the examples that I've been talking about, just so that I quickly go through a few bits and pieces before we move on to the next session. So, I'm going back to Drive, and I'm going to load up the line of function database presentations. Okay, so here's a simple function database. And I'm going to present and talk you through it and how it works. So yeah, I'm going to go to screen share. Okay, so this is the animals function database. If I click on this button, I have the first question: does it have fur? And if I click on yes, it then asks another question: does it chase mice? If I click on yes, it's a cat. And this button takes me back to the start. Now, just to show how this was set up and sort of things you would need to do. Here is the first slide, and if I decided I wanted to add another button, all I would need to do is use the insert tool. And it doesn't have to be the one that looks like a bevel button. It could be anything, it could be anyone if you like. And then all you need to do is add a hyperlink to whichever slide it is. Now, what I recommend to my students is that they use the title for the slide as the main part of the text, so they can see when they navigate through which animal is on which slide. That way, when they add extra slides, they don't have to remember slide numbers. Again, if they put the question in the title, they can, when they're navigating through, choose which question it is, and then each one of these, again, I'll just add a hyperlink to whichever slide it is. Now, it certainly does help to have them draw something out first. As I said, post-it notes are extremely good for being able to move things around, but it's not the only tool that they could use. You could, if you're looking for other apps, I like cuckoo.com for making up diagrams. And again, you could draw linked questions and answers in that to then use as a basis to what you're trying to follow up. Okay, there's a question about whether the presentation is available. Certainly, I've made it available on the Education on Air website, and I've also put my presenter's notes in there, which for those of you who found it difficult to hear, at least you'd have been able to follow it from that. Another thing that I can do, as I said, I've used a number of examples today. I can put links to that on my blog at 3.142.org.uk so that you can follow it from there. Good question. I will have to find the answer about. Yeah, there's a question about certificates at the end to prove that you were here, you did listen to it. I would have to find out from the education on air people, but I can certainly find the answer to that out before the end of today, and then post an answer up on the website here. Oh, that's an interesting question. Someone's just asked, can we do it first in PowerPoint and then copy to Google Slides? I've had some students do this with some degree of success. The important thing that I found with students working with both LibreOffice and with Microsoft Office, remember there are different versions of both, and your version may be different, so you may have to test it at your school. But we have found that it is possible to upload into Google Drive, open it within Google Drive, and then once it's open within Google Drive, it can then be embedded in Google Sites and modified. Obviously, if you're using proprietary tools from Microsoft Office, you may find that some of those proprietary tools don't transfer as well as you would like. And as I said, you may find that one version works better than another. There are certain advantages of using Microsoft PowerPoint. The obvious one is that with this presentation that I still have up on screen, one of the things that I've done is I've created an extra transparent rectangle so that it doesn't matter whereabouts on this screen I click. The only things which will respond to a button press are my buttons here. Everything else, no matter how hard or how many times I click, it won't go to it. However, that's not going to be the case with a slide without an extra transparent layer. If you look at this presentation, you'll see what I mean. It's something I used to do with older versions of PowerPoint around Office version 4. Nowadays, within PowerPoint, you can create what's called a kiosk application, and you won't automatically go to the next slide. Okay, it's past now, so it is time, if you're moving to another session, for you to switch to another session. Thank you for listening, and I hope you leave with something useful. Thank you, and goodbye.